Hello everyone, this is week 5 of our GATE problem solving sessions for physics, and as decided, so we are focusing on 4 topics, that is general aptitude, electromagnetic theory, mathematical physics and quantum mechanics. So these are the 4 topics that we would be focusing on, and the aim of these sessions is that we would be taking some questions from previous year's GATE physics papers from these 4 topics, and we would be solving them one by one in these sessions. And this is the 5th session in this series. This is week 5, and this is a 12 weeks course. So every Saturday we meet at 1:30 p.m. for a 1 hour session. And before we proceed, I would share some logistical details with you. So Saturday 1:30 p.m. that's the class timing, 1 hour session. Apart from that, we have a YouTube channel where you can go and you can basically subscribe to that channel, and you would find videos from the previous session as well as this current session, which will be live streamed. So I would just share the link of the YouTube channel with you people. For those of you who are joining us for the first time, so that's the YouTube channel. Apart from the YouTube channel, we also have a Google Drive link, a Google Drive folder. And in this Google Drive folder, so I would basically upload these lecture notes that I would be discussing. So I would share the link to the Google Drive. Just give me a second. So every week, the lecture notes are uploaded on Google Drive, and you can go and download those lecture notes from there. So I have shared the Google Drive link in the folder in the chat box. So that's the YouTube channel and the Google Drive link. And apart from this, we also have another platform which would be helpful for you people. So this is a Discord server that we have, and on this Discord server you can join the server and you can pose some questions if you have, and your friends and colleagues, and even I am there on the Discord server, so you can basically discuss amongst yourself as well as with me some doubts if you have. So I will share the link to the Discord server as well. So just give me a second. I will put the Discord server link. Are you able to see my screen now?
Yes, ma'am.
Okay, fine. Fine. Sorry for this technical glitch. Means I don't know why today my device was not connecting. It was working fine up until now, but somehow, even today I had connected, it was working fine, but somehow it got disconnected. So we will start now. So, someone from the last week had asked me a question about Levi-Civita symbols and how to write cross products and curls in Levi-Civita notation. So, this was pertaining to this particular question from electromagnetic theory that we did in the last class. So, this is not a question from this class, this is a question from the last class. And as you can see, this is a question in which we need to find out which particular vector potential is the one which gives us a uniform magnetic field along the z direction. And we are given a bunch of options. And how do we do it? Well, we find the curl of A for each of these cases, and that would give us some expression for B, and then we see whether it is uniform field in the Z direction or not. So that is how we do it. And so how we write in the Levi-Civita notation, the cross product and curl is what we will look at in this lecture. Just a brief description of the Levi-Civita symbols. So the Levi-Civita symbol is in the tensor notation given as follows. So if you have for three indices, because here we are dealing with, typically we will deal with three indices. So this is a Levi-Civita symbol for three indices, and this takes the value plus 1 if your I, j, k are in the cyclic order, I, j, k are in the cyclic order of 1, 2, 3, or 2, 3, 1, or 3, 1, 2. And this takes the value -1 if I, j, k is 3, 2, 1. This is the anti-clockwise order if you want to think of it, or 2, 1, 3, and it is 0 if any two indices are equal, if I equal to j, or j equal to k, or k equal to I. So this is your definition of the Levi-Civita symbol, and this is for three indices. If you have two indices, if you are in 2D, then you have simply ij, and again it takes plus 1 if I, j is 1, 2. It takes -1 if I comma j is 2 comma 1, and 0 if the indices are equal. So this is the definition of the Levi-Civita symbol, and it is plus 1 when if you have an even permutation, and -1 if you have an odd permutation. So that's the definition. So if you have even permutation, so this is plus 1 for even permutation of the indices, and -1 for odd permutation of the indices. So this is the Levi-Civita symbol that we have. And then using this notation, you can write your cross products and curls. So cross product in the Levi-Civita symbol is given as follows. So this is how you would denote your cross product, and then you have curl. So that's your curl, where, okay, let me remove this. So where this del I is basically the partial derivative with respect to the coordinate I. So that's how you would write your cross product and curl in the Levi-Civita symbol notation. And however, even with this notation, you do have to solve for each of these parts A, B, C, and D one by one, and check them whether they satisfy B is equal to del cross A, giving us B as a uniform magnetic field. There is no way you can get around this technique of trying to put in each of these values and checking whether you get the desired uniform field or not. Someone in the last class was asking about Levi-Civita symbols. So that's why I am discussing, briefly discussing this Levi-Civita symbol in this lecture. and someone basically wanted to know if there is some shorter way of trying to solve this instead of uh, brute force trying to put in uh, each of the options and then trying to see if it satisfies or not. So unfortunately, there is no other way other than trying to brute force put in each of these options. So that was a brief intro about the Levi-Civita symbols. Now we move to this week's content. So this week we start off as like always. We discuss few questions from general aptitude and then few questions from either one of the topics: mathematical physics, electromagnetic theory, and quantum mechanics. So this time also we will start with a few questions on general aptitude. So this is the first question over here for general aptitude. It says the variable cost of manufacturing a product varies according to the equation V is equal to 4Q, where Q is the quantity produced. The fixed cost F of production of the same product reduces with Q according to the equation F equal to 100 over Q. How many units should be produced to minimize the total cost? So it's a very simple problem on minimization. So here we are given some equations and we need to find out for what value of Q we will have the minimized expression. So let us start by writing the expressions. So total cost of production of the product is given as T is equal to V plus F. That's the variable cost plus the fixed cost. And then what we have is we put in the expressions. So this is 4 times Q plus 100 over Q. That's the individual expressions for V and Q. So that's our total cost. Then what we need to do for minimizing: minimization would be achieved by the derivative of t with respect to q and setting it equal to 0. And how do we know it's a minimum and not a maximum? That would be by checking the second derivative. So if the first derivative is 0 and the second derivative is positive, then what you have is a minimum. On the other hand, if your second derivative is negative, when the first derivative is 0, then you would have a point of maxima. So let us differentiate it. So our derivative dt over dq is 4 minus 100 over q squared, which we set to be equal to 0 for minimizing. So this gives us that q should be plus minus 5. And from this, we can select q equal to 5. Why? Because negative value is unphysical. The quantity of the product cannot be negative. It can only be positive. You can't have minus 5 products of something. So negative value in q is unphysical. So that gives us with only one option, and clearly if we put it in second derivative, the second derivative would be as follows. And this at q equal to 5 would be the following, which is positive. So indeed, q is equal to 5 is the point of minima. So that's the answer. Coming to the next question. A container originally contains 10 liters of pure spirit. From this container, 1 liter of spirit is replaced with 1 liter of water. Subsequently, 1 liter of the mixture is again replaced with 1 liter of water, and this process is repeated one more time. How much spirit is now left in the container? So let us see how to solve this problem. So what we have here is amount of spirit. So amount of spirit left in the container after n such iterations of taking 1 liter out and replacing that 1 liter with water would be given as follows. So 10 liters is what we started with, and then we keep taking 1 liter out and replacing it with water, and n is the number of times we do this. So n is number of times that 1 liter is replaced with water. And this term over here, this term, so 10 liters is the original amount that we start off with, and this term right here is, sorry, so this term over here is the fraction, it's the fraction of spirit left, fraction of spirit left. For our case, n is equal to 3 because we are doing this process 3 times, this process of taking 1 liter and replacing it with water. So in this case, n is equal to 3, and what we have is the following, which is equal to 7.29 liters. So that's the correct option. Moving on, now we have two questions based on English language. So as you know, in general aptitude, in GATE exam, apart from physics questions, you also have some English language based questions based on vocabulary, some basic grammar. So we also discuss these English language questions, which are taken from the previous year's GATE physics examination. So let us look at the first one. Choose the grammatically incorrect sentence. So could people just put in the chat box which is the grammatically incorrect sentence and which is the correct answer for this particular question? So I give you 30 seconds to select the answer to this question before we proceed further. So quickly, if people can type in the chat box what the correct answer is. I'll wait for some time till the time people respond to me. Okay, someone is saying C is the correct options. Okay, C is the correct option. Someone is saying other. So can other people also select some option? Okay, so correct answer is indeed C. So C is the grammatically incorrect sentence over here. What should have been the correct sentence? this word over here, instead of less, it should have been lesser. It's kind of like comparing things. So the committee initially asked for a funding of 50 lakh rupees, but later settled for a lesser sum. That should have been the correct sentence, and that's not the case over here. So it is incorrect. Just writing less is not the correct uh, way to write the sentence. Okay, so let's proceed. Which one of the following options is the closest in meaning to the word given below? And the word given is mitigate. So these are the four options: diminish, divulge, dedicate, and denote. So quickly, if people uh, can respond to this question in 30 seconds, I'll wait for some time. People can type in the chat box what the correct option is. If someone is saying A, okay, great. So A is the correct option. And as we all know, Oxford Advanced Learners Dictionary is one of our favorite dictionaries to follow. So according to Oxford, to mitigate something means to make something less harmful or less harmful or less serious, and so on. And synonym of this would be alleviate. So instead of mitigate, if they would have written alleviate, that would have meant similar because it's a synonym. And one example phrase is action to mitigate poverty. So diminish also means to reduce. So diminish and mitigate are close in meanings. So the correct option is diminish. Now that completes the section on general aptitude for today. And today the topic that we would be focusing on is quantum mechanics. So we have a few questions on quantum mechanics that we would look at. So the first one is, which of the following is an allowed wave function for a particle in a bound state? And we are given some options. We need to select which of these is basically a proper wave function description. And n is a constant, and alpha beta are also constants which are positive. So again, if people can respond before I start, if people can write in the chat box what they think would be a correct wave function, and then I will discuss in detail as to how you can identify which wave function is an allowed wave function description. So quickly, if people can write in the chat box. Okay, wait, is my screen gone again?
No, ma'am.
Can you still see my screen or not?
Now it is visible.
I
Oh no, it is not now.
Yeah, I'm let me just see why it's going again and again. So I hope it is visible now back again, right?
Yes, ma'am.
Okay, fine. So could someone just type the answer what they feel is the answer for? Okay, someone has already written. Fine. So let us start by understanding how we can identify which wave function is the correct description. So when we have a wave function, so a wave function is a solution to the Schrodinger's equation. So and allowed solutions of the Schrodinger equation are what is known as the wave function. So what kind of wave functions are allowed? Well, wave functions should be single value, they should be finite, and they should be continuous. And this is true for not just the wave function and also for the gradient. Even gradient needs to be single valued, finite, and continuous. Then wave function should be bounded at large distances, which means it cannot tend to infinity at large distances. Then if there is an infinite potential step, if you have an infinite potential step, then in that case the wave function is zero at the surface. And finally, wave functions should be square integrable. Wave functions for a bound state need to be square integrable, and square integrable means that this integral is finite. And if this integral is equal to 1, then that means we have a normalized wave function. So if this finite constant equal to 1, then we have what is known as a normalized wave function. So let us look at the options. So option A is undefined at r equal to 0. It is not finite. So when you put r equal to 0, you get infinite value. So that means A is not correct. Similarly, as r tends to negative infinity, side tends to negative infinity for part B. So it is not bounded at large distances. And D, option number D, if we look at, then this is discontinuous at r equal to capital R. Why? Because r greater than r, it is 0, and r less than capital R, it is some non-zero finite constant. So it is discontinuous at small r equal to capital R. So that leaves us with option C, which is indeed the only correct option. And we will look at some plots for this wave function. So if you focus along the x direction, wave function along x direction, that means if we look at psi x where y is equal to 0 and z equal to 0, then we have the following. This is for option C we are looking at. So that's the wave function along x direction, and this is the corresponding plot we have. So clearly from the plot you can see that it is finite everywhere, and it tends to 0 when your x tends to plus minus infinity, and it is continuous, and it is definitely differentiable. So this part is fine. Similarly, we can look at wave function along either the y or z direction. For option C, that would be psi x equal to 0, y and let's say z equal to 0. That's nothing but an exponentially decaying function as given over here. So this is e to the power minus y squared or minus z squared. Then you can have in two dimensions if you want to look, setting x equal to 0 and y and z. That is, this is your wave function for part C when x is equal to 0, and the corresponding plot for this is given over here by this 3D plot over here, 3D surface plot. So again, you can see that it is finite, it is bounded at large distances, it is continuous and definitely differentiable. So from these plots also you can see that option C is the correct option. So this option is the only correct wave function. So let's proceed further. A particle of mass m is confined in the potential. In the following potential, it is given half m omega squared x squared for x greater than 0 and infinity for x less than equal to 0. Let the wave function of the particle be given by psi x equal to negative 1 over root 5 psi naught plus 2 over root 5 psi 1, where psi naught and psi 1 are the eigenfunctions of the ground state and the first excited state respectively. The expectation value of the energy is, and we have a bunch of options. So we need to find out the expectation value of the energy. Now this is a half parabolic potential. Half parabolic. And the traditional harmonic oscillator that we study is for the full parabolic potential. Full parabolic potential means that it is half m omega squared x squared for all x belonging to real numbers, and half parabolic potential is when it is when the potential is half m omega squared x squared only for positive x and it is infinite otherwise. So let us look at some plots for the traditional harmonic oscillator. So here are some plots for wave function and the probability density psi squared taken from Wikipedia's website on a quantum harmonic oscillator. So we are given some 8 wave functions over here. This is for the traditional harmonic oscillator that we study with the full parabolic potential. And the energy in this case, so this right here, this plot is for the full parabolic potential, and the energy for the full parabolic potential is given as follows. E is equal to n plus half h cross omega, where n is the state that you have. So n is 0 for the ground state, n is equal to 1 for the first excited state, and so on. So n denotes the energy level. So this is for the full parabolic potential. Now coming to the half parabolic potential. So this is our question. Our question is based on half parabolic potential. And this is the potential given as follows. It is parabolic for x greater than 0 and it is infinite otherwise. So this is the case when we have infinite potential step. And if you remember from the previous question, I had written that if you have infinite potential step, then the wave function is 0 at the surface. So for infinite potential step, your wave function is 0 at the surface of that infinite potential step, which means in this case, wave function is 0 at x equal to 0. So this is the infinite, this is the half parabolic potential. This is the plot. So you have half m omega squared x squared for x greater than 0 and infinity otherwise. So this is the potential diagram. So that means we need to select those wave functions, those wave function solutions to the Schrodinger equation of the full harmonic potential which satisfy the condition of it being 0 at x equal to 0. So the condition is psi x equal to 0 is equal to 0. So only those wave functions which satisfy this condition would be the wave functions for the half parabolic potential. So let us go back to our diagram and identify which of the wave functions are having 0 at x equal to 0. So you see this wave function is 0 at x equal to 0. So this is an allowed solution. This wave function is 0 at x equal to 0. So this is also allowed solution. Similarly, these solutions which are x equal to 0, which are 0 at x equal to 0 are the allowed solutions of the half parabolic potential. That means that psi 1 of full parabolic potential is now my psi naught of half parabolic potential, and psi 3 of full parabolic potential is psi 1 of half parabolic potential. So you see that this psi 1 is like the first eigenstate, psi 3 is like the second eigenstate. So in every alternate eigenstate of the full parabolic potential is selected, which are the solutions for the half parabolic potential. So in that case, my energy, so let us look at what is our given state. So our given state is this given state for the half parabolic potential. Given state is psi of x is equal to negative 1 over root 5 psi naught of x plus 2 over square root 5 psi 1 of x. So that means expectation of the energy is negative 1 over root 5 squared times E naught plus 2 over root 5 squared times E1. So these are like the probability amplitudes of getting E naught and E1. So these coefficient squares would give me the probability of getting to that state. So that is 1 over 5 times 3 by 2 h cross omega plus 4 over 5 times 7 by 2 h cross omega. So E naught in our case is 3 by 2 h cross omega and E1 is 7 by 2 h cross omega from this formula, where n would be equal to 1 and 3 respectively. So this is nothing but 31 over 10 h cross omega. So the correct answer, as someone rightly pointed out in the chat box, is A, which is 31 over 10 h cross omega. So coming over to the last question for today. So for a spin s particle in the eigenbasis of s squared and sx, the expectation value of sx squared is given as, we need to find out which of the options is correct. So we need to find out the expectation of sx squared. So let us start solving the question. So in this question, we will make use of the ladder operators. So s plus is sx plus isy. These are the ladder operators, raising and lowering operators. So from this, what you get is sx is half of s plus s minus. So sx squared can then be replaced by this raising and lowering operators. This is sx squared, an expectation value. So simplifying it, basically opening up the bracket, note that s plus and s minus operators do not commute. So you can't just write 2s plus s minus over here. You need to write s plus s minus s plus, because these are non-commuting operators. And let us write down what the action of s plus and s minus do. So s plus, this is the action of s plus on the state. So as the name suggests, it is the ladder operator and it is raising operator. So this will raise your state by 1. M goes to m plus 1 for s plus. And if you have s minus, then your m will go to m minus 1. And this is the corresponding coefficient for it. So from this, what we get is that expectation of s plus squared is 0 and expectation of s minus squared is also 0. Why? This is because that the states are orthogonal. So because the states are orthogonal, these terms over here would be, the overlap would be 0. So therefore, our expectation of sx squared is given as follows. That's because s plus squared and s minus squared, their expectation are 0. And this term right here is nothing but 2 times s squared minus sz squared. You can verify this. So this is the expression. So what we get is the following. And this in turn would then give us the following result. And why? Because this s into s plus 1 comes from the expectation of s squared, and this m squared comes from the expectation of sz squared. So expectation of just sz would have given you simply m, and if it is sz squared, that gives you m squared. So the correct option is option number A. So these were some questions on general aptitude, quantum mechanics, and one question from electromagnetic theory we discussed again from the previous lectures. That was just to understand, just to see a brief overview of the Levi-Civita symbols. So that's all for today's session. In the next session, again, we will look at some general aptitude questions and some mathematical physics questions. So that is all for today, and I'm extremely sorry for all the technical glitches that we had today. This was not there earlier. I don't know why today there were some problems with the network and with the connection. So as a result of it, I was not able to connect my device to share the screen, but hopefully after fixing it, it was fine. So I'm really sorry for having wasted so much of the initial time on trying to fix this network issue. Hopefully this does not crop up again.